Thank you so much for joining me today on Dynamo BIM. Today we have a Dynamo chat. We're super lucky to have Taco, who's joining us today from the Netherlands. He has brought us a custom package called MEPover. It's an MEP package that deals a lot with electrical systems, electrical circuiting, different things like that. I've gotten tons of use out of it. I'm so thankful for Taco. You guys all should be too. You don't know about the package. Taco's going to tell us about it today. And I'm super excited because he's going to talk about some of the custom nodes that I haven't played with. So without further ado, we have Taco. How's it going, Taco?
Hi, Dana. I'm doing quite all right. Thank you.
Thanks for joining us today.
Yeah, you're welcome. It's a pleasure. If I go down to my package and under parameters, there is a section collector. And these are some of the filter string collector nodes. And I'm just gonna go ahead and show it's what it can do. So if I go, for example, filter string begins with, so it will ask you for a parameter input and a search value. Now here in the Netherlands, we have a classification code, which is what we use for classifying all of our elements based on a national standard. So if I look at my model and I click just a random element, and if we did our work correctly, then it should have a classification code under the IFC parameters. And it says 57.71. So everything that starts with the 57 is there, and then everything behind the dot is sub-classification. So let's say I want to find everything that is of the classification code 57. So I'll just type in my classification code parameter. Did I do this correctly? Yeah. All right, and then I input the 75 begins with, and when I hit run, you can see that it'll take this short and then 7,000 elements. Now, if you were
That was
to,
so fast.
yeah, it is really, really fast.
Wow. And so that looks through every different category, just essentially all elements in your model that have this value for that
Yeah,
parameter.
exactly. What I did was in the Revit API, there's a you have a few classes, and basically most of it doesn't do everything in the model, but it does everything that is a host object and all its children, which is basically every system family, and family instance and all its children, which is basically every loadable family. So
pretty much all bases covered. You got system families and loadable families.
exactly. And so unless you get some really weird category,
Maybe like some in-place weirdness, even maybe
in-place
even like
masses, stuff like that.
right.
Yeah.
Yeah.
But for most of the stuff that you want to find, it works really, really, really fast. And as you can see, you get ducts, you get air terminals. So if you wanted to do this in the normal way, you would first have to get all the elements of all the categories and then filter the parameter of all those elements. So the starting number of elements would be a lot more than 7,000. And then you'd have to process them every one of those elements. So it would take maybe multiple factors slower than this node. So
Yeah,
there's
not to mention that you'd have, exponentially a lot more nodes, right? So it'd be
exactly.
lot more to read through.
Yeah, so this is really, I really like this node, and maybe because it sounds a bit, it has a strange name, doesn't really, maybe you don't know what it does, so I thought maybe a little explanation would be in place. And there's a
Yeah, and
few
it's
others.
awesome. Yeah, I was about to say, it looks like you have a contains, does not equal. So you could look at these collectors in a bunch of different ways to
Yeah,
gather elements. That's really wonderful.
exactly. And this works with shared parameters and native Revit parameters, and does not work with non-shared parameters. Um, but you know, uh, I really think you should use shared parameters for most of your important parameters.
Absolutely. No, I'm thinking about all kinds of different use cases that I could do with this. I mean, essentially, this is treating a group of elements as a group, right? Like you could essentially give, all of your elements a consistent parameter value across multiple categories, and then treat all of those elements like a group. Update them all simultaneously as a group in
Yeah,
that way. That is amazing.
exactly. And it also, I believe it also does type parameters. So it does instance and type parameters. So if I do description, and then it should be able to find. Let's see if this is. So that's Dutch.
I knew it wasn't
So
English.
let's. So it had canal in it. So let's see if that works. And there we go. And it returns the ducts with the description type parameter with canal in the description. So it's a really fast and fast way to search your entire model, both on an instance and type family basis. So it's really one of my, when I started Dynamo graph, it's a really useful way to find some of the elements that you need. Now these are all string parameters. It does also work, for instance, with system type. In the Revit API, that is basically an element ID, but does work with these nodes because the actual value that you put in is a string. So I might add some filter numeric values in the future, but it takes a bit more work than the string nodes. So that's it in a nutshell for the filter string nodes. And there are some other nodes that I'd like to highlight, and those are not the collector, but the connector node. So it's two different, not the L, but the N. And for that, I'm just gonna show you. I'm gonna open an empty project. I believe we have one over here, yeah. Right. I got a Finkel unit, and a Finkel unit has a lot of different connector types assigned to it. So there's like air supply, there is hot water, cold water supply in return, there's sanitary out, and also an electrical connector. So it's really an item that has a lot of different system types attached to it. Now, if you open a family with connectors in it, you will see that there are you can see all these connectors in the family environment. So if I zoom in on it, you can see that this is the connector. And this connector has some properties, it has a system classification, a flow direction, a shape, and same goes for the running supply. So I say that does not have a shape because it's always round, but it does have a classification. There's all these properties assigned to your connectors, and you can access these properties in your project as well using the connector nodes. Now, and why is that useful? Well, you can use these connectors to build your ducts and pipes up from. So if I go back to my project and copy this Finkel unit a few times, I'm going to place it in a few different stations. Yep. All right, so I'm going to switch over to the 3D view. Now, normally when you model these friendly units, you can drag your pipes off from the connectors and, place your ducts and pipes. But we can also automate that by using Dynamo and the connector nodes. So I'm just gonna go and give you a quick example. Setting up those graphs can become quite a big, can become pretty complex. So I'm gonna take a few shortcuts, but the principles of what you can do and achieve using those nodes, try and show those. So let me first get those Frankel units into my graph. Yep. Nope. Nothing. Yep. All right. So I have my 5 Frankel units, and if you go to the MEP Over, there is the connector tab and element connectors. So if you plug this in and hit run, you can see that it will return all those connectors that we just saw in the family environment. Now it just says connector, so you don't know what each connector is. Is it a system, air system, or is it an electrical connector? So there are a bunch of other connector nodes as well that we can use to retrieve all those properties that we just saw in the family environment. And I am going to try and model a piece of pipe from the sanitary connector. And maybe also some ducts from the duct connections. So first off, I'll take the connector system type. If you take that, you can see that it expects a connector input. So if I drag that in and then hit run, you can see that it will return the system types of your connectors. Now, using this information and some of these other nodes as well, you can filter down your connectors until you get the connector that you want, and then use that connector for creating your pipe or duct. So I'm just going to go through that process now. So I've got 3 air, or no, I was first going to do the sanitary pipe connector. So I want to filter out this sanitary pipe, and as you can see, it returns the connectors in a random order, because here the sanitary is the second one, and here it's the last one. So I'm going to have to filter by its name. Now, I just saw that you did a video on data types on your channel. Really useful, because all too often, I think, especially when people are just starting out, they will get quite a lot of errors that involve type mismatches. So the object type node is really a useful node for seeing if anything goes wrong when you get an error with your node. So if I plug this in and run it, you can see that it actually returns not a string, but some kind of Revit API class. So I do not want that. I want a string type, so I'm going to create a string from object. And there we go. And now I want to filter out my sanitary connectors. So let's go ahead and say X equals.
wonderful use of a code block, which I also talked about in my
Yeah.
with my data types.
Yeah. I'm not a big fan of design script, when it gets too complex, I usually reach for a Python node because I think Python is a way easier language than design script, but the code blocks are really nice, Just single or two line pieces of code can be really useful. All right, and then the filter pattern. So I'm just going to go through the most obvious and nodes. So just for testing purposes, run. As you can see, we retrieve the sanitary connector. So now I will plug in the actual connector. Oh, sorry, it's not the actual connector. This is the actual connector. So now I have retrieved every sanitary connector, and now I can look up its location by taking the connector location. There it is. And also the direction. And every connector has three directions or normals, the X, the Y, and the Z. And the Z is this node for the direction. Is always the direction pointing out of your connector. So this is like the direction of the pipe out of your element. So if I hit run, I now have the points of these connectors and the direction. So if I want to create a pipe, I can do so by that's the nice thing of the piping. You can actually create a pipe by a connector and a direction, I believe. I'm gonna look at it. And we have pipe by lines and connectors. Not like connector endpoint. I actually got 3 of them. So if you've got two connectors, you can actually create a pipe between those two connectors by using this node. And there's also that pipe by connector endpoint. So you input a connector and an endpoint. So in this case, I'm going to start with my connector. And then my point is going to be some distance from the connector. So I'm going to translate this point in the direction of the way the connector is pointing. So I use the geometry translate node distance, input the point and the direction, and the distance can be anything you like. Maybe 5 millimeters. I'm a metric guy. So go, and then you'll get a point that is just 500 millimeters from the connection. So this is basically my endpoint. I'll plug that into the point. Then all we have to do is supply a pipe type. Type. Right, and I'm gonna first plug it into the name node, because this will give me all the names of the pipe types. All right, so I don't really care which one it is right now, so I'm just going to go with that first one. Plug that into there. And the level is varying right now, so just have the first available level. Obviously, you can do a lot of filtering and sorting to get this just the way you want, but for demonstration purposes, I'm just going to do it like this. And if I hit run now, we should get a piece of pie. Oh wait, I think I need to flatten my notes. I'm just gonna flatten the points and the connectors. Yep.
It's always wonderful watching somebody work in Dynamo. I feel like I'm picking up so many little tidbits of, just
Everybody
watching
has its
someone. It's so
own, yeah,
wonderful.
and everybody has its own kind of way of using it, and you learn
Right.
something from
You just
everyone,
like
I guess.
see your mind working almost. It's great.
Yeah, yeah. So if I hit run now, check my serial. There we go. So yes,
Lots of pipe.
every Fenkel unit now has a pipe sticking out, just a little bit. So this is nice, there's not a lot of automation in this example. There's only 5 Fenkel units, of course, but if we continue now and also do the ducts, we could supply every connector on this Fenkel unit with a piece of duct or pipe. Especially in MEP, it can be useful to do this. You could build off of this and maybe create another piece of pipe upwards up to the main branch. If it doesn't get too complex, you don't expect to be going, don't expect to create entire um, networks of pipes, but it's really useful for an initial piece of pipe from a fixture or in this case, an thinly unit. So there is some room for automation there. But as you can see, the graph really starts. This is just a small one, but if we continue now and also do the ducts, you can see that it will quickly start to become quite a big graph.
But
All
still
right.
much simpler than what I would have anticipated for something that's quite complex, right? I mean, you're actually getting elements, getting a connector from that element, filtering the connectors down, then drawing geometry from those points. I mean, I would have thought that it would have been at least 3 times the amount of nodes, but because
Yeah,
of the MEPover package, I mean, you're getting the connectors, you're getting the connector types, and then you're creating the pipes. I mean, it really is simplified down
yeah,
through the process.
yeah, it is. Yeah. But it really depends on your project and the type of families you are supplying. It's in other in a real project, I used this one, and then I had to do some extra connector filtering before I finally had the connector that I wanted. So that was maybe twice the nodes as we have now. But still, it's doable. It's doable.
Yeah,
And you could,
absolutely.
yeah. And, so shall I continue with the
Please.
ducts? Yeah. Right. So I'm just gonna maximize the screen for maximum viewing pleasure. All right. So if we go back to the start, and as you can see, I first filtered out the sanitary. And what I'm going to do now is filter out these 3 supply air connectors. So I'm just basically going to do the same thing. Instead of sanitary, I'm now going to use a string contains node, because there is also or maybe I could just say air. Yeah. Well, if you had a return air here as well, maybe you could have filtered with just a string contains node and search for air. Then you would have all these uh, ducts in one go, but in this case, we can just do supply air. Right. And let's go this as well. So I'm just going to drag this down a bit. All right. Now, for creating ducts, there is sadly no by connector endpoint available in the Revit API. So we're going to have to go with, first off, we're going to have to choose a round or a rectangular duct. So we're going to have to filter those connectors as well. So luckily, there is a connector shape node. So we can take that. Then I can input the connectors, and then it will give me the shape of the connectors. And as you can see, these are all round. So if you want to filter this, and once again, you will have to convert this to a string first, I believe. Let's drag this one over here. It will give me a, oh, it already is a string. All right. So, well, that's great. So, usually, if you have like a round and a rectangular in here, then you'd filter for maybe round. And smooths. All right, so let's see. Right now, it's not doing anything, of course, but there we go. So now you get all the round connectors, and otherwise you take everything connectors over here. Now, if we go to the duct connectors, I'm going to create the round one, a round duct by lines, and this expects a duct type. Now, it would be nice if you could have input a, it would have been nice if you could have made like a branching pathway in your graph for round and rectangular ducts, but there is no way to filter a duct type by, you cannot see if a duct type is a round or a rectangular duct type other than the naming conventions that you use. So there's nothing in the Revit API that will say, oh, this duct type is rectangular and this duct type is round. And you're going to have to filter it by the names that you give it yourself. So, or no, I don't think that's, I don't think that is true. I mean, I'm just going to, so if I get all my duct types, I believe that it says rectangular or round duct in the family name. So, and type name, I think I'm just going to use the round T in this case. So get the first one, plug it into the duct type. Okay, and then we also have to supply a mechanical system type. So then I will look up mechanical system type and do the same here. Go, so we run, gives me the system types. Now these are some Dutch. This is the Dutch word for supply air. So I'm just gonna pick that one. 3. All right, then get to my system type. And then the level, just level. Now the diameter is going to be defined by the connector as well, because that has a size. So I'm going to go back to the connector. There is a connector, is ramp. So I'm going to take this one and then plug it into here. Let me just bypass the shape connector because we don't really need it in this case. So put that aside for now. Yep. So the next size. So the size of connectors. This is, of course, once again, imperial because Revit internally works in inches. So if you want to,
Luckily for me.
luckily for you,
Not for you.
not lucky for the rest of the world. But so you're gonna have to convert this to, at least I'm going to convert it to metric value. So I'm gonna multiply it by 3.8, or you can also convert it with the converter assembly, right? I never use it, but
Yeah, it looks like you got the math down.
yeah, you need to. Yeah. So if I hit Ctrl again, you'll see nice metric rounded values. Yeah, all right. So that's the radius, and I want the diameter. So I'm just gonna multiply this once more by 2, and then I have the diameter of the duct. Yeah, and then get into diameter. Now all we need is a bunch of lines. For the lines, we can kind of do the same thing as we did with the pipes, with the geometry and translate node and the connected direction and location. So let's grab that and with the connectors. Yep. So now instead of a connector start point, we are going to use this point as a start point for a line, and this is endpoint for our line. So to create a line by starting with endpoint. And once again, back now it's a bit to the right. Start point, endpoint. All right, so hit run now. Go, and I don't know if you, I always disable my I set the background 3D preview for Revit because I find it kind of annoying, but as you can see, this is the line that we just created, start point, end point. And then we have a bunch of lines, 15, and a bunch of types, diameters. Yeah. So I'm just gonna, to be sure that the node will work, flatten them all. You know, you could use the, I believe the listed level works pretty good, but I've never really tested it out on my own nodes, to be honest. Yep, and this should work. Yeah, all right. Now, the only thing is that they are not yet connected to the fan coil unit. You know, the great thing about the connector, the pipeline connector, is that it already connects it to the connector. And right now, this is not yet connected. So the last part we have to do is connect the connector of this duct to the connector. A bit more complex than pipe node. All right, so we have these ducts. Now I'm gonna have to find the. I'm gonna have to connect these ducts to these connectors. So I have 15 ducts over here. Connect to, yeah. So connector connect to node. Now we have to filter the connectors on this duct, on these ducts. So I am once again going to get the connectors node. to retrieve the connectors on these ducts, and there will be 2 connectors on each duct. And now, which connector is the connector that needs to be connected to the connector on the Venco unit? You can actually connect connectors that are not physically in the same place. So if I would just take the first one and connect it to the other connector, then you'll probably see that maybe the connector on the far end side of the duct will be connected to the Venco unit, and in Revit there will be an actual connection. But that is not really what you want. So we're going to have to find out if which connector is closest to the other one. Now, what you can also do, in this case, we know that the connector that is closest to the Venco unit will not have the same direction. It should have the opposite direction of the node, of the connector on the Venco unit. So that is one way to find out. You could also, I'm thinking of other ways to find out if that is the correct connector. Of course, you can do a location distance to the connector that is the closest to the other connector. But I think that this works a bit faster. Just gonna. All right, so I use this connector direction. All right, so yeah, and believe there is a factor equals. Factor almost equal to, right? Almost equal to, yeah. Factor is almost equal to. So it's going to work. Yeah, and then direction, yeah. And then, of course, I will have to do some list at level magic. Lots of souls. What? I want this to operate at one. This to operate at level 2, right? Right. Oh wait, I'm not. Oh wait, I'm not doing this. This is not the correct. I got 3. Oh wait, yeah, okay. Correct. Let's keep connected there. Just let that down. That would be easy. Then my people lists. Let's start over. Go. Okay, that's easy. All right, so as you can see, we now have one false, one true for every list. Yeah, so I'm just going to filter that through a blue. And then use I'm gonna double check it quickly by inputting the vector nodes or the direction node, and then these vectors should be the same as these vectors in direction to -1, 1, 1. Yep. That looks good. All right. So then I'll input the actual connectors instead of the directions. Run it again. And now it should need the connectors. Yeah, so Now I have 15 connectors on this side, and I have my 15 connectors from the ducts. Sorry, from the sprinkler units. Where is it? Oh, no, wait. I've got my 15 connectors on the ducts. Yep. And then I need my 15 connectors from the sprinkler units. Drag it over there. All right, well, as you can see, it starts to get more complex. 15 connectors. All right, so this that list, and then I'm going to connect the connectors from the sprinkler units to the connectors of the ducts. Fingers crossed. Oh, 15 is almost. Oh, wait, I think I need to take this one. Oh, it's a lot of scripts. That's fine. Yeah, all right. There we go. All right, so I took the wrong output. I took the is equal to is true, but it should be the other direction, of course. So the of course
Now they're all connected.
this side of the duct has the same direction as the connector on the Finkel unit, and the connector that is in the opposite direction should be connected to the Finkel unit. And now they're all connected. This seems a bit underwhelming for 5 Finkel units, but you can imagine if you have your entire project filled with Finkel units and you want to start connecting them.
Absolutely.
You know, you could do that. You could place that first piece of pipe, in one go, and then connecting them to the main branch becomes a lot easier because you can just start trimming in Revit. You know, the trim command is one of the favorite commands for every MEP modeler, I think. Trimming pipes and ducts works really nice. So having a first piece of pipe coming out of your equipment can be really useful. Yeah. So that's it in a nutshell in terms of what you can do with the connector nodes. And right now we went through it pretty quickly, and I can imagine that you want to set up some extra filters for maybe filtering names of your system types. And maybe, of course, you could also set up your families to include a description in the connector. So you can filter for connector description as well, because there is also if you look at the connector nodes, there's also a connector description node. You know, so you could also supply your family with some custom description in your connector and then filter your connectors that way. There are a lot of other nodes as well. You can also find a linked connector for elements that are already connected. So if you have, like in this case, if you have a duct, get all those connected on the duct and then use this linked connector node and return the linked connector on the Finkel unit. So that way you can traverse your entire network of ducts or pipes. Well, and there's a lot of other connector nodes as well. The host element will return this is actually the reverse node, the inverse node of the connector element, or the element connector. So this will return the pipe that the connector belongs to, or ducts, or it. So that's it in a nutshell for the connector nodes, basically.
If somebody has to do this by hand is going to save so much time with these workflows. Like you said,
Yeah.
adding some additional filters or rather than the selection node, actually having it so that it grabs all the elements from a level or what have you. Definitely some ways that you can customize this for yourself to make it much more functional for your projects.
Exactly. Yeah. And there's also one map connector info plus, which basically packs all these or most of these nodes into one. This was the first one I started out with, but it's a bit of a big. It put in an element and it will return its connectors, its points, flow direction, all these properties in a single node. But of course, that's going to be a bit
It's
slower.
awesome.
Yeah,
Yeah,
it's
gives you all the
can be used
information
to.
though.
Yeah,
So
exactly.
what would you say for some of the people within the industry that you help out with, or maybe they contact you? What are some of the common things that you get asked in terms of some things that they want to be able to automate or restrictions that they get through API, in the Revit?
Yeah, most common things. Well, the funny thing is that I created these nodes because I started digging into the Revit API and I was really mindful. And then one of the first nodes I created was the pipe by lines or the duct by lines. And when I created it, I thought, well, I don't know what good this node is, but well, I exposed this Revit API method and maybe somebody will find some use for it. And the funny thing is that once the node was published, people in the Dynamo forums actually started asking questions about the nodes, and I was like, oh, people are actually using it, even though I myself don't use it all that often. It was good to see that a lot of people did actually use all those nodes for creating pipes and lines and T's and elbows. So I get a lot of questions on those, on the T's and the elbows and the automatic creation of pipe networks. And to be honest, sometimes it's just hard to create something that you to create an entire network the way you set out to do. If you create, for instance, if you create a T on a pipe, and Revit, if you use the native Revit command from the UI, it will actually split up that pipe. It can just shorten your original pipe and then create a copy and then place a T. So one of the two pipes will have a new element ID. And the same thing goes for the T by two map curves. That's a node I have. It will create a T on a pipe. But of course, one of the pipes is only one of the two pipes will retain its original element ID, and the other one will get a new element ID. So there's no direct way to get that new pipe into your graph for downstream usage in your graph. So there are some limitations, and so there's a lot of questions on those kinds of things. Also, what I also see, and there are also a lot of questions about propagating information through a network. If there's Revit itself does supply for ducts, for instance, it supplies a way to propagate the flow through your entire network. So you get a aggregate or a sum of your entire flow at your air handling unit, where the totals are. But for pipes, it doesn't work that great, or maybe not even at all. So there are quite a lot of questions on that as well, if people can automate that in using Revit. So I have a few notes for that as well. But it really depends on a person's project or a company's standards, the way they set things up and how they connect things and type of families they use to really make good use of those nodes. So for instance, I have I believe it's the pipe upstream. I have a few nodes actually. I have the duct upstream components. So if you input a duct or a duct element or an air terminal or whatever, it will look at the flow of the ducts and find all elements upstream. So up to the air handling unit, for instance. There I also have a node for just getting the entire network based on a system. You mentioned this one as well, for the electrical circuits.
I love that one. That is one that I have definitely used quite a bit of.
Yeah, and it's a really simple Revit API method. Just it's not a lot of code, but it's really useful.
Totally.
Here it is, duct system. Yeah, so you can supply a duct system, and it will return all elements in that system. So those are nodes that I think people often use, because in the end you really want to, for the MEP, you want to have all, the systems are like they hold a lot of information. People really want to know a lot of information about every connected element in the system. And this doesn't only apply to ducts, but of course also to pipes, because pipes in the real world work the same way as ducts. You want to know how much water flows through it, and that flow will define its size and the friction and all. There's a lot of calculations going on that will define how the pipe network will look. And Revit itself is kind of limited in the options it offers you for automating that. A lot of people are looking for ways of doing that in Dynamo, and I hope that my notes help them in just the
Certainly
slightest
has helped
way
me.
possible.
Certainly has
Yeah,
helped me.
it's really great
So
to hear.
how can people get a hold of you?
Well, you can find me on LinkedIn, of course, and I also frequent the Dynamo forum a lot. At least once every day, I will take a look at all the new forum topics. But I have to say, I'm not as active as I used to be, but I hope to be a bit more active again.
You've mentioned to me recently that you are going to start maybe taking more time to develop more and maybe
Yeah,
even do some freelancing on the side.
yeah,
Is
yeah. I
this
really
something
want
that
to. Yeah,
somebody can reach out to you on, and if they are interested in maybe getting some help with Dynamo or
yeah,
the API related to MEP and Revit?
yeah. Absolutely, yeah, that would be great.
Well, Taco, this has been so great. I can't tell you how much I am, because specifically I have, have an architectural and interior design background. So when people are asking me MEP related questions, I have definitely used you as a resource in your custom package. Thank you so much for that. And thank you so much for joining me today and showing me some of your package and some of the things that now I know exist and I can use. So it has been really wonderful.
You are very welcome, and thanks for having me.
Absolutely.
It's been a pleasure.
And thank you everyone for joining us today on Dynamo Chats.